This video we're going to be talking about rates of reactions and things that might influence whether they go either faster or slower. So one of the things that affects reaction rates usually is the concentration of the reactants. So for example, imagine that you have this reaction where these kind of orangey green things collide with these pink things. Okay, so first of all, the only way these two molecules can react is if they collide. And so the more often they collide, the more often they can get over the activation barrier to go to products. And so if we have twice as many in this container as we do in this container, that is on a per volume basis, so the container size is the same, the number of collisions between a pink and a kind of orangey green thing there is 4 times higher than it is for this, okay? And so there's like 4 different ways these will collide, and this is only one way. And so if the rate of reaction depends on the concentration of the pink stuff, if you double the amount of pink stuff, the rate will double. If it depends on this kind of orangey green concentration to the first power, if you double it, then the rate will increase double as well. And if it depends on both of them, then 2 times 2 is 4 times faster. Okay, so you can quantitate these, but for the most part, we're going to just say that in general, the rate of reaction does depend on the concentration. So that's why most reactions actually start to slow down as they proceed, because you start with a high concentration of reactants, say like here, and then they start to collide and go to products. And I'm not drawing what the products are, they're there. And eventually you might at some later time have this much left, and then even later have even less left. So what happens is the reaction starts out at a high rate, then slower and slower and slower, and eventually just stops. Okay, the other thing that you can do to increase the rate of a reaction is to lower the energy requirement. Okay, so if the mechanism involves, for example, the collision of 2 things to get to products, well, it'll have a certain activation energy. However, that's not the only way you can actually make something. So if you add a substance called a catalyst, what it can do is actually provide a different pathway for the reaction to occur. And so it doesn't change the energies of the things that are reacting. You can be running at the same temperature, but what it does is it provides a lower pathway. So it's kind of like, you know, the Red Mountain Expressway road cut gives you a lower mountain to go over than going through the top of Red Mountain. Okay, so that's how catalysts speed up reactions. Because for a particular temperature, more and more molecules will collide with enough energy to get over the barrier if it's a lot lower barrier. And the third thing that actually contributes to the rate of reaction is the temperature. As you heat up the reactants, they start moving faster and faster on average, and that means the collisions on average are more and more likely to be great enough to get over the activation barrier. Okay, as a last note, biological catalysts are usually quite efficient. The speed up of the rate could be over 1,000,000 times over the rate of the uncatalyzed reaction.